In this lesson, we described functions as either even, odd, or neither, depending on the symmetry the graphs of these functions had. So this really doesn't have to do with polynomials. Even, odd, and neither deals with any function we could possibly deal with. However, we're going to look at it currently in terms of polynomial functions. But before we get into that, half the graph of f of x is shown below. Sketch the other half based on the function type. So I give you a graph of a function here, and I want you to graph it so that this function is even. Remember that even functions have symmetry across the y-axis. I can reflect it across the y-axis, and I should get the same thing. So I need to take this piece of the function and reflect it across the y-axis. Well, that point doesn't move because it's on the y-axis. If I reflect this across the y-axis, that point ends up there. This point's 1, 2, 3, 4, 5 away, so it needs to be 1, 2, 3, 4, 5 away, and then down 2. So if this function was reflected across the y-axis, now it's an even function because it's symmetrical about the y-axis. It has symmetry if I reflect it over the y-axis. Odd functions have 180-degree rotational symmetry about the origin. So if I take the function, spin it around 0, 0, 180 degrees, do I get the same thing? So we need to take this piece of the function here and rotate it 180 degrees about the origin. So if I rotate this 180 degrees about the origin, that point's going to end up there. This point 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 5 is going to become negative 5, negative 5, 1, 2, 3, 4, 5, 1, 2, 3, 4. That's that new point there, and then this point is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 8. 3 is going to be 6, 7, 8, negative 3. Negative 3. I can count boxes. So the big idea here is now if I take this function and rotate it 180 degrees about the origin, take your paper and spin it and look at it upside down, do you get the same function? And the answer would be yes in that case. This one, if you fold on the left here, the even function, if you fold it across the y-axis, that function is going to land on top of itself. It's something that we're going to be looking at all year with every new function that we introduce ourselves to. Is it even, is it odd, or is it neither? So how do we algebraically determine if f of x is even, odd, or neither? And here's how we do it. We plug in a negative x. We plug in a negative x. We see what we get. If you get the original function back, if you get the original function, it's an even function. If you get the opposite of what you started with, so if you change the signs of everything, it's an odd function. So if you get the additive inverse of what we started with, every sign is changed, everything is now negative, everything that was negative is now positive, everything that's positive is now negative, it's an odd function. So it's sometimes we struggle with how to plug in negative x. So I'm going to switch over to the chicken nugget variable. F of chicken nugget is 3 times chicken nugget to the 4th minus 7 chicken nuggets squared plus 5. That's what this means. Whatever is inside this parenthesis gets put in for that x variable. So if I'm finding f of negative x, I'm doing 3 negative x to the 4th minus 7 negative x squared plus 5. So we plug in negative x into our function. That's what we always do to algebraically see if it's even, odd, or neither. Well, if I take negative 1 and raise it to the 4th power, you can use your calculator. Negative 1 times negative 1 times negative 1 times negative 1 is going to be positive 1. So this is just 3x to the 4th. Minus 7, well, what's something negative squared? Negative 2 squared becomes positive. So negative 1 squared, that negative there becomes squared, so it's x squared plus 5. Well, wait a minute. This is what we started with. That's f of x. That's our original function. So because f of negative x equals f of x, we say f is even. Because we got back the original function, when we plug in the negative, we get back the original function, which means if you plug in let's say here's a point here at 3. If you go over here to -3, it's going to have the same value, which means it can be reflected across the y-axis. So we say it's even. That's how you algebraically determine it. Plug in f of -x. And we end this homework by looking at graphs. Describe each function as either even, odd, or neither. So, describe each function as even, odd, or neither. So, we look at this graph of h of x here. Is it symmetrical about the y-axis? Can I flip it? Can I rotate it 180 degrees about the origin and get the same thing? Or does it have neither of those? And if you fold your paper along h of x there, this has symmetry when reflected across the y-axis, which means this is an even function. If I look at this graph over here, if I take it and reflect it across the y-axis, I clearly don't get the same thing. I clearly cannot reflect that across the y-axis and get the same thing. Now, it looks like maybe, well, if I take this origin here, the key thing is we're rotating it about the origin. Do I get the same image back? If I was to take a picture of this here, let's see how this goes. If I was to take a picture of that, well, that did not work the way I wanted it to. But if I was to so take your paper, spin it upside down, do you get the same thing? And the answer is actually no, you don't. You would not get the same function because it's not symmetric about the origin. It's symmetric about this point right there. You could spin it 180 degrees about that point -1, 0, but that's not the origin. So this is actually neither. It's not even, and it's not odd, so it's a neither. It's neither even nor odd. So this is not even or odd because I cannot rotate it 180 degrees about the origin. I want to do it about 0, 0, which didn't work. So it is neither. It's neither even nor odd. So that's all it is. Can I reflect it across the y-axis, or can I rotate it 180 degrees about the origin? If it's one of those, it's even or odd respectively. If not, it's neither. This is gonna follow us all year. We're gonna practice it all year. Just wanted to introduce it in this lesson here. We return to our work with just working with polynomial functions for the rest of the unit.